2020 was a year of terrifying surprises. As the COVID-19 virus made its way across the globe, we were all unsure of what was to come. We were optimistic that this virus would run its course quickly and we would be able to resume to our normal lives. But then came 2022. After more than 20 months of living in what felt like a simulation, the virus attacked the hardest it ever has. Omicron, the most contagious variant of the COVID-19 virus, infected more people in the United States in the month of January alone than it did in the previous 5 months combined. The demand for testing was at an all-time high, especially in densely populated areas such as State College. The Pennsylvania State University was fortunate enough to have testing made available to all students, faculty, and staff, but with hundreds of vials needing to be processed daily, Penn State's Testing and Surveillance Center was met with a challenge. Current methods of testing samples by hand was not fast enough to keep up with the massive influx, so the task team purchased a TCAN robot to expedite this process. However, the caps that these tests came with were not compatible with this automated machine. Our group was given the opportunity to work alongside the task team in developing a new design for the tube caps so that the robot could perform PCR testing faster than the current methods. We began our project with some preliminary concept generation. Between all members, we sketched nearly 70 unique designs as possible solutions to this compatibility issue. Refining these ideas into 3 concepts, a twist cap, a push cap, and a snap cap, were 3D printed with a standard PLA filament. While some concepts printed nicely, others failed due to complexity issues. Outsourcing our model designs to a company that has better resources was too expensive for our given budget, so other methods of 3D printing were explored, including the use of SLA printing. While this method improved the overall quality of the prints were still lacking in some respects. How would we ensure that these biologically contaminated vials did not leak during transportation? Can this rigid material survive the negative 80°C temperatures when stored in the freezer? Will the caps withstand the forces of an accidental drop? With all these uncertainties, our team chose to experiment with a flexible TPU filament next. The team eventually directed the attention towards the snap cap. This design proved to meet the needs of our sponsor better than the other 2 designs. Many revisions led the team to the final prototype that sealed properly, survived the extreme temperature changes, and withstood several drops from the table height. The self-sealing mechanism eliminates the need for additional components and aids in the ease-of-use design constraint initially developed by the team. With this final prototype, we hope the task team will be able to perform testing at a faster rate than ever before.